Okay, let's look at first how we compare different marks and why these Z-scores are used. And we'll look at it in terms of HSCs and assessment marks and things like that. So hopefully it's something that you can relate to. Now, this isn't the way the Board of Studies does it. I'm not sure how the Board of Studies does it, but if I was on Board of Studies, this is something that I'd look into at least. Let's suppose this is the marks that you've sent in as your students' assessment marks. Now, I don't know what the mean is there, but let's say it's 70. Now, when they've done the HSC, this is how your students actually performed. They performed really, really well, and instead of a mean of 70, they've got a mean of 80. So your assessment marks that you've sent in are quite a bad representation. So what the Board of Studies could do is they could change your mean by sliding up your mean. In other words, add in scores to your assessment task. But still, it's still quite unfair because the shape still isn't the same. And these top students got more than they deserved compared to the HSC mark, and the bottom students got less than they deserved. So we've changed the mean, but we haven't changed the standard deviation. So again, if we change that standard deviation and we try to get your assessment marks as close as possible to their HSC marks, and that would be a fair representation. And the way we do that is by changing these means and standard deviations so they are the same. And in that way, we can compare the two marks. How does this relate to the standardized form? The standardized form is exactly that: a mean of 0 that I've got up here and a standard deviation of 1, which now we have. So what we've done is we've taken your test results and we've done two things. Here are your test results, and we've slid them so that the means are the same, and then we've merged them or mucked around with the spread so the spreads are the same until both of those are pretty much identical or identical in this case. So that's why Z-scores are used, and any bell-shaped curve, doesn't matter what the mean is. The mean could have been more and the standard deviation really thin like that. The probabilities are still 1, remember. The probabilities of being 1 standard deviation above the mean or 1 standard deviation below, all exactly the same. All we've done by using Z-scores is slide them above and then muck around with the spread so they match up perfectly. Hope that explains that a little bit better. Thanks. Bye.